start? Ke nak tunggu? Asal aku? Aku rasa aku tulis.
Yang what is plasma?
Ikut kau lah. Tak ada skrip, okey? Duduk tak ada restriction, tak ada registration.
tak ada rumah apa?
Okey. Jom. Mana lain nak indak semua?
Ada semuanya.
Oh, okey. Nak start.
Assalamualaikum warahmatullahi wabarakatuh. Welcome to our coffee talk for this semester. Today we'll have Dr. Saiful to talk about plasma. We have solid liquid plasma.
That's my script, okay?
Now we learn and discuss the fourth state of matter, the plasma. What is plasma? What do we know about it? How can a plasma form? Come and join us.
That's my script.
So without further ado, Doctor, I'll invite you to start this session.
Okay, thank you. So somehow, coincidence or not coincidence, I don't know, because this is the fourth time, right? So it's a fourth method, fourth states of method. So I think quite nice, the timing there. Okay, so I think you're already familiar with the state of the states of matter, right? So we have solids, and then we have liquids, and then after we supply more energy, we become a gas. So what is plasma actually? Any one of you have heard of it? I think it's not a new word, especially when you take biology, you encounter with the plasma, right? That's a different meaning. So most of it, there's a time when there's a conflicts when we are giving the names of these four states of matter to be a plasma, because actually both of them can have the same, almost similar properties. Okay, almost similar properties, because a plasma can consist lots of particles and ion can sit down together. The same almost with the plasma within a body. Right? Okay. So what is plasma? Plasma is really if you go to the movement of from the first state, solid, liquid, and gas. It's actually the increase of energy. Okay. And so as you add on more energy, you go to the another state. So another state, at the end, it will reach to a plasma state, which has the higher energy compared to the gas. So it's almost like a lecture right now. I don't know how to make it more. Introduction. Yeah, introduction should be formal. I hope it's not formal, too formal. No taking notes, eh? No, I'm not sure whether it will be reliable or not. Okay, I just want to share my perspective, my view regarding on these topics, so you can expand your universe. Okay, expand your universe, go beyond that what you have seen. So that is our specialty in physics. We can expand our view in the universe as we go along. Okay, so back to the point. Okay, so as you increase the energy, you go to the higher state. So the end of state is the plasma. So you cannot go beyond that. Okay, you can dismantle the particles more, even more smaller, complex. But that's not a state of matter. A state of matter is to make it more. Go back to the fundamental understanding of what is state of matter. Is a condition where we can have a bulk of particles or molecules that can sit around together. So that's state of matter. So if you bombarding in the accelerator, going to much more fundamental particles, so that is not a condition, or it's not a state of matter. It's already gone beyond that. Okay. So plasma, the uniqueness of plasma, okay, compared to the other state of matter, solid, liquid, and gas, is that this condition of plasma is not just can stay on a specific temperature. Okay, so if you go to let's say if you at a solid, obviously it should have a lower temperature. Okay, it should at the condition of solids. But the property of a plasma, sometimes we can observe it in a solid form, also in the gaseous form. Okay? So that is one of the uniqueness. Another uniqueness of the plasma itself is that it behaving more than just what we expecting. Okay, what I mean by expecting. But before that, okay, it's much more easier if I were to compare it with the gas. Okay, because the gas, how does the gas react with each other between it? It's just a collision, between it. So it's just a matter of mechanical movement, which has been described by the Brown movement. But for plasma, there's more than that. Actually, for plasma, it have less probability. In order to achieve the condition of plasma, it should have lesser probability of collision. Why? Because the plasma, I forgot to state what is plasma. So plasma actually is constituted of a ionized particle from gases. As you increase the heat, it will have the sufficient energy to ionize. So what is meant by ionize? To release the valence electron. Okay, to release the valence electron. And then this release is not just removing away from it. It will still, the electron still lingers around the particles. And then this condition, okay, because to create this condition is very hard. So I just state out, as it go release from the valence band and then go beyond that, and then this electron and the ions will have the tendency to stay together. Okay, stay together. So these are the conditions that make plasma much more different compared to three-state matter. That's why I think it was not introduced to you during your high schools. Okay, okay. So go from the state of plasma. Okay. So the electron, as it goes separate and create an ions and electrons. Okay, an ion also can be negative ions. So it's a matter of charge. Charge. So this charge will stay together because we know that there's an attraction between a positive and negative. As it tries to go along, it will create an electric fields, and then it will after some time, because of the pulling force is greater, it will draw back. Okay. So that is the nature of the plasma, part of nature. Another nature of plasma is depend on the collective behavior. Okay, so this is one of the most difficult thing to measure the plasma movement, the ion movement or the charge particle movement, because it's not just referring to the collision, okay, the reaction of the momentum, conservation of momentum, but it's also depend on because when a charge moving, it will produce a magnetic field. This magnetic field will experience by another charge a magnetic force, and then an electric, as a charge moving from one point to another point, it will change the properties of the electric field, also produce an electric force. So it's a combination of both electric force and the magnetic force. Okay, and then this randomness, the randomness of the gases also have made us very difficult to predict. So we have the Monte Carlo simulation to produce the randomness. Okay, to produce the randomness. So that's why from that randomness, because we cannot actually predict, take particles, a container, and then it's not that we can snap, so that we know every initial movement from start. We try to make our simulation, cannot. So what we can do, we play to throw some dice. So that is what is meant by Monte Carlo, because actually the Monte Carlo was developed, what I heard, and not go directly to the history, it was developed for the gambling purpose, but somehow it have been useful for our scientific observation. And then maybe part of my explanation is a bit not accurate, okay, because this is purely from my observation, okay, mixed from lots of my understandings. So it's like I'm creating my universe of understanding. Maybe it's not that correct, okay, but it's just matter of conceptual. if we want to go correct, more accurate, we will have to go on mathematicals. We have to more do a simulation to look at whatever the. So I'm just trying to explain the condition from the fundamental knowledge. I think that most of you already have familiar with. Okay, so this condition, the uniqueness of the movement and the availability of the electric charge and the magnetic force that are available due to the continuous movement of the positive particle and negative particle, it will bound both of them together by an unusual characteristics. Okay, in such a way that if I have an external charge of positive and negative particles, so if I have a positive charge, let's say, so it will draw out the electrons. Somehow I can pull up all the particles away and break down the plasma condition, but that's not necessarily happening because of this collective behavior. So whereby as soon as there's this plasma experience an external electric field, it will disturb the distribution somehow. It's just disturb the distribution. So when it's disturbed the distribution, it's much more easier to us to look what it disturbs. So we have the ion and we have the electrons. Okay, so from both of these, the electron have more tendency to move compared to the ions due to its relative less mass compared to the ions, the electrons. So what happens? This electron will drive toward the positive charge outside the plasma, and then at this cloud of electron moving away from the we try to look at that moment the ion is still stands still, and then this cloud of electron will drawn away from the plasma, but as soon as it go to a certain distance, it will draw back, because as it moves, this cloud of electron move away to the ions, the positive ions, it will create a very high electric fields, so it will draw back. So as it draw back, it will actually vibrating. So it's vibrating. So this called the shielding effect. So actually when we have this plasma, it will have less tendency to the interference of the electric field outside of this its region. Okay, so that's lots of details of physics. So where we can find plasma? Okay, so the question lies on how can I answer that, because where does the plasma lies? I might as well it lies somewhere here, because why? I can create it. So there will be two types of plasma, created and the natural plasma. So we go back to the natural plasma first before we go to the how close the plasma lies in our life. So the natural plasma, most scientists have agreed that this plasma construct the universe 99%, maybe more than that, maybe 99.9%. So that 1%, where does the lies of 1%, very less than 1% lies, actually is on Earth. Okay, most of the non-plasma condition is on Earth itself. So that is another question. Why? Yes. So why is Earth? So you have to go find the truth. The truth is always there for us to acknowledge. And so this plasma. So what are the first candidate we want to show? The sun, the stars. Okay, the star, the unlimited energy. Okay, is produced by plasma. Okay, so the sun. Okay, how does the sun can sustain lots of energy? Okay, to sustain lots of energy, actually, what is meant by sustaining lots of energy? First, if you have lots of energy, but it will disperse at very short of time, it doesn't use. It will not be useful. But how it can refrain for a very long time? Even if you have very small energy, And let's say you create a battery that can last 1 year. It's very convenient, very convenient because you can control the power going through it. So the sun. So the sun have the capability to burn its fuel over and over again, in such a way that only a portion of the energy will release. Compared to if you just have the hand grenade, throw it somewhere and explode. So it have very high energy, but it was released at instant of time. So if a sun was have the same properties of the hand grenade, it will explode. It still not be useful. So we doesn't. There's nothing interest about it. So this plasma, what is the energy released by this plasma? Okay, why is very in terms of energy? It's not a chemical reaction. Okay, it's not a chemical reaction. The plasma inside, if you can draw, it's almost like a chemical reaction, but it's more on a fusion reaction. Okay, a fusion reaction. So going back a fusion reaction, there's lots of branches. So how does plasma make it possible to make a fusion? That is a question, and that is the most question, because people currently are trying to bring the plasma that was produced on sun towards Earth, okay, inside the Earth. Okay, so maybe I go to just one example of nature of plasma. Okay, there's another nature of plasma. If you look at the, if you have gone to Google's, there's lots of galactic gases, okay, galactic gases, okay, and then you can see lots of beautiful colors, okay, beautiful. Those colors, I think it's not the visible lights. It's not producing like the visible wavelength that you have seen. Actually, it just matter how you describe. Okay, this amount of intense frequency of X-ray have this color. So let's go beyond the topics. So it just reproduce our perceptions. Okay, our perception for visible color is this range. So for X-ray, we don't actually see anything. So we put it to have a certain range, so that we know that at this point it have a certain range. So that is a perspective. So that galaxy gases also a part of the plasma. Okay, so if this plasma outside the universe, because it likely to lose any energy because it's not contacting. Okay, the vacuum, the outer space is surrounded by a vacuum space. Okay, vacuum space, there is nothing on. So this plasma can remain energy without losing any. Okay, if you have a hot pot, afterward it will lose its energy because of the convection, conduction, or even radiation. Okay, it's a bit scattered away. Maybe I should stop for a while. You will have
So in the beginning you said about the plasma,
okay,
the fourth state of matter. So you said that we in our early years we learned that the main characteristic of matter is that it has mass and
it should located in a group. So if I just take one particle, I cannot say that although that I have a positive ion and then negative electron, I cannot say that a plasma is not a state of matter, because it has to be a group of particles. So that only that we can categorize that it's at a certain state of matter.
So why is it the high? So because that's the reason why the high. If we apply even more energy, for example, in the early universe is the quark gluons slope, right?
Okay.
Why is it not considered because of the higher energy state?
Okay, good questions. Okay, so we have to ask ourselves. Okay, you said just now is a very good question, because I never thought about it, but somehow I think there's a sense of it, because during those time it was starting from the Big Bang, right? Okay, so what are the Big Bang and what are before the Big Bang, and what are we staying right now? So what are the difference? What is the difference? the volume. Am I right? The volume. So as it's expanding, it's cool down. It's cool down, it's go down the states. Okay. So right now, I think we will not see the groups of quarks and gluon mix up in the form of states because it's already been cooled. So the same happening in the plasma. Okay. If a sun doesn't have the confinement mechanism, it will break down. It will break down and then it will disperse its energy, and then after that it will reduce the state of a plasma to a gas. Okay, because it's not confined to any volume. So what holds the sun to remain at this condition is the gravity. Okay, so if you have look on the Spider-Man movie, the first generation. No, not the first. This Toby Maguire. Toby what? Toby Maguire. The second one, okay. Is the Doctor Octopus, is it?
Yes.
Doctor Ock. Okay, you have looked at. He's tried to make a sun in Earth. So what he have done, the conceptual were put inside. He tried to confine this gas plasma in such a way, confine, and then it will make a dense core. So after somehow, if it managed to do that, it will have its own gravity to confine it. Okay, if not, but eventually it will it end up with, I don't remember what happened to it. It absorbs everything, right? Okay, so it create a very high gravity. So it's almost like a black hole, but it's not that powerful. But if you have a very concentrated mass, so this mass is very concentrated, although it's very small, it will have the gravitational pull more than the Earth itself. Okay, because of the inverse proportionality of the R, the center of mass and the R. Okay, does it answer the question?
So for another one, you say about natural and man-made plasma.
Okay.
So is the plasma ball is the type of
Plasma ball.
the one people use to
Yeah.
show, and
So
follow-up question is lightning considered plasma?
yes, lightning also plasma. So a man-made plasma, we can categorize it as high temperature plasma or low temperature plasma. Actually, the sun is quite high temperature plasma, but most of the what we currently the advancement of the making a fusion from a plasma, they able to create a plasma temperature higher than the sun itself. So how can we hold that kind of hot? Why does we still have our Earth, although that the temperature is beyond the sun, although that the sun is far away, and we felt the intense of heat, but a man-made plasma have gone beyond the temperature of sun. So how can we survive that? How can we survive that? Actually, the Pendafloor, okay, the Pendafloor also using plasma, okay, a discharge plasma, okay, a gas discharge plasma, and this temperature is very high. In such a way that temperature managed to melt down the glass itself. So, but why it managed to not able to melt the glass? Confinement of heat. Time. How does time relate?
Too short amount of time.
Okay, so I think I got your what is your opinion? It's actually the heat capacity. If you have one electron very energetic, with million times of the kinetic energy of the sun itself, but eventually it goes out, it will release. It will distribute itself, and no one will notice that the kinetic energy of the electron itself. So that the reason is the mass itself. Okay, if you have the sun, the whole sun put inside, put closer, even the Earth will absorb by the sun due to its very large mass. So if I have a very dense, high temperature sun in my hand here, it will surely melt the Earth. because of the heat, the heat capacity that inside of it is able to disintegrate the earth itself, because the energy, if you have the energy, and the energy is described by the temperature and the mass. Also, although that you have very high temperature, but the mass is very less, so actually the energy is not much. Okay, the temperature is high, but the mass is very low. The energy is not much. The temperature is very less, just slightly higher, but you have a very large mass. You still have lots of energy. So that is the conservation of energy. So what else? What are the useful of this plasma? What we have been used this plasma right now? So that the property of plasma itself is very. This is one thing. Yeah. Okay. If you look at the pendafloor is the plasma discharge doesn't produce the white light. So what it produces actually a UV light. You know that? Okay? So what cause it change to produce the white light is the fluorescence coating. It's the phosphorus. The phosphorus. So if you right now how your phone possible to produce lots of color is due to the blue LED. Again, using phosphorus coating, it will produce many colors. Okay, what else? The plasma. Okay. The plasma have been useful to our life, but especially medicals, disinfection. Okay, what do you call it? Sterilization process. If you try to purify your air. Okay, I think when you surveying an air conditioner, you will get a plasma or an ionizer that actually use a plasma. So a plasma is what I said just now. But what it produces inside of the aircon is just a spark. Just a spark. The spark is actually a very small lightning. If you want to make it easier, it's a very small lightning. So this spark is a movement of electron and the ionized. The electron is jumping, and then electron is very energetic. It will bombard with the gas surrounding. So how it can purify your air? That is the question. How can it purify the air? Because of it ionize the dust particles. Okay, ionize the dust particle, and then it will ionize another another heavy particle, and then it will combine. So it make the particle heavier. So eventually, when you put out your aircon, if you notice with ionizer, if you put in your room or anything, you will find out there's lots of dust. Lots of dust in your room is a good thing actually. Okay, because the dust goes down instead of in your air, right? Okay. It must go somewhere. As it goes down, if you should put a lower height filter so it can absorb. So if you don't want to clean up, or you can have the robot vacuum moving around. It will cost you more than 1,000 ringgit. To the one is very useful lah. If you just buy cheap one, maybe just circle around one point and not go into lots of places. So the one I really like and interested to discuss with today is diffusion. Okay, diffusion. How men are trying very hard from 50 years back. Okay, during the first atomic bomb was developed, there's only two ways. One is fission, another one is fusion. So there's lots of argument why we're still struggling after 50 years. Still fusion is not achieving. For fusion, they managed to do it within very short of time. Most of them said that due to the money. Okay, the one that drives fusion is the war, and war can produce lots of money. So it willing to invest lots of money. Okay, and fusion. Okay, fusion. So to create a fusion, there's lots of expensive experiments have been done throughout the world with very likely to achieve, and we can only think of solving a problem. After solving a problem, there's another problem came in. Solving a problem, another problem came in. So, and it still in that kind of process, due to the probably because of lacks of collaboration, lacks of funding, because of when you want to collaborate, you have to have a manpower, right? And then when you want to have a manpower, you should have a salary to pay them, because everyone at the end want to eat, right? Although you want to cover the problem of power deficiency, but eventually what we actually needed is food and drink, right? And place to stay. So everyone needs to eat. So money fundings, most of the time, what is the main point of that drive or fuel up any kind of research. Okay, so what are the candidates that is currently producing this fusion reaction that hopefully we can generate not similar to the sun, but have the break even. Break even, that which means that if you put this amount of energy, you get back the same amount of energy. So that is meant by break even. So what are the candidates? We have lots of candidates. One of them is tokamak, steriliter. The reason one collaborate is ether. And those 1, 2, 3, the one I just mentioned, actually, to make it simplify, is the one that at the heart of the Iron Man. Do you know? The one is the circulating around. If you look back to the first Iron Man, it has the very large glass globe, and then there will be some kind of blue wave moving around. That is a confined plasma. They're showing that like it's already there, but still under construction. They could produce it, and for ITER project, they could fuel it up to 40 seconds maybe. I'm not sure about the time. And jet is a tokamak, so it also could produce some kind of that range, but it's not that continuously. Okay, so they even provoke that maybe one time that scientists can put it inside the heart of a very portable, very small, unlimited energy. Actually, it's not unlimited. It's just increasing the efficiency of the fuel to its mass. Okay, if you have 1 liter of petrol, you only could produce 1,000 joules. You use deuterium, just 1 milliliter, you can produce 100,000 of joules. So actually, but eventually you still need soft fuel to consume it. How can this? What are the mechanisms? Okay, I will go to a bit on again, then I open for a question again. Okay. So how does this fusion? I think I have to explain back what are the fission and fusion. Do I need to explain it? What is the difference fission and fusion? Okay, fission is the break, fusion is the combine, but eventually break. So you get both. Okay, when it fuses, you get energy, and when it break, it will get energy also. So this process is circulating in the sun. So that is too much to expect to produce in our in Earth, but as long that we can produce very efficient of fusing and have able to absorb all those energy, that is more than enough. Although that we have to put in lots of deuterium inside or tritium inside. So the method is again to confine. As I said just now, if a plasma doesn't have any mechanism that bring it together, it eventually collapses. Because as I explained just now, a plasma, it vibrating. So this vibrating, somehow it will be unstable. Okay, it will unstable. That is part of it. And then there's another very interesting happening. Instead just vibrating, that this thing doesn't experienced by the all other states of matter is the radiation cooling. Radiation cooling. Radiation cooling, if you look at the black body radiation, everything goes on black body radiation, right? You have a certain temperature and then it will cool down due to the radiate energy in the infrared region. But for plasma, this radiative cooling is due to because the electron is free to move, and it goes and it move somehow it accidentally move towards near the atom and lose its energy, kinetic energy, it will radiate electromagnetic wave. Okay, you have look at you have know it in the photoelectric effect, right? As or inside the Balmer series or all those series, hydrogen series. And then this I'm a bit scattered because I never taught a lecture for this plasma. So somehow I explain something. I think I said I have to explain this part. So actually just now I want to explain regarding on the confinement, right? Confinement. So confinement. Let's say I choose a tokama. Okay? A tokama is like a donut. So how you drive the plasma is to produce a drive magnetic field. Okay, a drive magnetic field such a way that it's a jump for the current to flow, and then it will produce plasma, and then this plasma will try to have the stability, and as the plasma moving, okay, it will produce a current. So this current will produce a magnetic field. So this magnetic field will pressed, okay, due pinch of the it will pinch the current, the plasma itself. So this will remain as long as it can, as long as it reach the stability, and then eventually collapse. So to produce that, there's one thing. The stereolator is to have the magnetic field generated by the plasma itself. So to have the magnetic field generated by the plasma itself is very difficult, because you know that for a free charge moving, it will not just moving like or drift like a normal current flowing inside the conductor. Okay, it's not happening like that. So it's gyrating. So there will be a movement. So the movement also describe the magnetic field. So to have the current induce the coil outside, and then the coil outside, due to the induced current, will produce a magnetic field to confine back the plasma. We have to predict the movement of the charged particles as it go inside the stereolator. Okay. So to do that, just recently, about 2000. I'm not sure, because during my PhD time I'm kind of in a vault of time. I don't know which period is that. So maybe around 2013 or 14, they confirmed that they're able to predict the simulation of the movement, and then they have produced very complex coil in such a way it can reproduce the induced magnetic field. Okay, the induced magnetic field to help confine the plasma, so it can sustain longer. So maybe you ask a question. Maybe you have a question inside your mind. Why we want to eat longer, right? Why we want it longer? Because we want it to be burned longer. Okay, to be burned longer and to produce. Actually, we want to produce what? Neutron. Okay, the most valuable is to produce neutron. Okay, as we get the neutron from the plasma, we will get this neutron to heat up a wall. So this heat again will heat up a liquid, and then this liquid will drive the motor. So there's no other way compared to solar. That is the only way, having the heat to drive a dynamo. Eventually we'll end up with that. Very complex everything, and then eventually what you go to there, and then do the water.
Heavy energy.
Maybe we can use either despite of water, we can use other materials. There's one project, very innovative project, but I miss one loop of the rationale, whereby they use nitrogen. Okay, you know that a server is very hot, require a cooling, right? A cooling mechanism. You have to put an aircon inside of it. What they do is, this server, they put inside of nitrogen liquid. So this server will produce heat. This nitrogen liquid will have the heat, so it will expand. So it becomes the external combustion engine, like your dynamo, or like a steam engine, but using a nitrogen. So, but what I don't know, how much does it require to compress back the nitrogen? And somehow it will have, because if you have learned thermodynamics, you should have a heat sink also, right? You should have a heat sink also. So for nitrogen, obviously it have very low heat sink, right? So that is a question, but that one I didn't figure out why, because this one is a recent project got by the UTM and some of the green company. I'm not sure what the names. So that is eventually it end up to the dynamo. Okay. So unless you figure out something, right? Because we cannot, as the neutron goes to the wall, because the same concept was used in a fusion reactor. Okay, it absorbs the neutrons, and this due to the heat produced by the neutron, it will heat up the water. Okay, maybe not necessarily water. It have a liquid metal, because it have higher conductivity, so it have the much more efficiency to distribute and then the water will less exposed to the radioactivity also. Okay, go back. So the fusion, okay, that is trilateral. So the Stokama is almost the same, but the difference that it produces the magnetic field to confine the plasma is external. It is external. It's not reproduced by the plasma itself. Okay. So these people are still racing with each other, which of them will produce the longest plasma, or the one that able to get the break-even condition. So that is the plasma confinement. Another one is the inertial confinement. The inertial confinement, this one is very exciting, and it's very interesting how people able to put lots of money, and how the scientists able to convince the investor to produce lots of things just for very small thing, which only have the probability. It's not the 100 probability to achieve to success, but a matter of probability. Especially how they managed to have the fund to create the sun itself, and then it took 40 years before they achieve. And then somehow during the 40 years, the people are still have their families to support, right? So they still have to be paid by someone. Although that the sun experiment, it's not that it will produce higher crops growth or anything, right? But it's still people still want to fund it, because I don't know. Maybe those people who fund also a physicist, maybe going to a business part. We don't know. Maybe one of you will come back to USM and fund our research personally. Siapa tu? Okay. So what? Okay, the inertial confinement. So the inertial confinement, what is very interesting. I heard one talks by the Dr. John Parsley. Dr. John Parsley, he said that the inertial confinement. How does the inertial confinement works? and in their laboratories is to compress, okay, to compress the explosion of a fuel plasma, okay, to compress a fuel plasma. So we have a deuteriums confined inside a tablet, okay, that can be explode. So inside of the pellet there, it was put inside of a gold. What you call it is hologram, or hologram. So this hologram, there's a holes that can allow a laser to penetrate through. Okay, to penetrate through. So this laser is not just a point laser, or it's not just one laboratory laser. It's a whole building laser. It's a whole building laser, and just to produce that, to fire up this laser, it will cost $1 million. I think what I remember is almost $1 million. Okay? So how it works? It will, all this laser light will separate it into a few sources, and then it will illuminate the surface of the gold hologram. So this surface, the laser and the gold surface will produce an X-ray, a very intense X-ray, and then this intense X-ray will heat up the deuterium pellet, and then after sufficient amount of energy, it will explode. Okay, so this explosion, okay, this explosion and it's a bit complicated to explain this, because there's a two ways. Okay, one is explosion, another one is the external force. Okay, so the internal explosion, as it burn the fuels, the external also confined, so it will somehow create a very high density. So that is somehow to make it more simpler, because to explain with the diagram much more easier. So right now it's just my hand moving around. I'm just assuming that you can imagine it. Because my mind is imagining the slide that Dr. John Pasti is giving it to me, so my mind is always there, but I'm producing it with my 10 fingers. I'm not sure about that. So the question is, why is they still not able to achieve it? First, again, the money to run that, to fire up, it has to confirm all the condition. This is good, because they cannot afford a mistake. You cannot afford, because it requires lots of not energy, it's lots of money, funding, the cash flow. So you might think that, might as well go to the simulation, right? Much more safer. We don't have any cost on that. I think for those who are working with Dr. Yun, I think you already have thought of the problem. Okay, why? Because there's lots of conditions, lots of variables to consider. Guess how long does the simulation took? As you run it, it will take more than years to have the results. People there have to do something, right? So they cannot just wait. Don't worry, we just holiday 1 year, and then we wait for the result, and then we look how it comes. So it still took quite a time. And then during that time, maybe there are lots of possibilities, endless possibilities, because when dealing with a plasma, which is collective behavior, so we try to break a code. We didn't even know the length of the codes. If we have the code for our Facebook, let's say there's only 8, so we can easily crack it up. Right now, we don't even know what is the length of the codes, and we don't even know the code itself. So it's continuous of possibilities. Possible, this is possible. When it possible, it might possible to the other way around. So to create this condition, the possibilities is always there. So that is why the drive. This is why. This is the reason that drive the scientists to push through, because to them it's just a matter of steps away. Okay, although that it push back a few steps back, but it's just a matter of steps away. So wait for a while, take a question if you want to drink tea. I'm afraid of this. At first I want to come, I'm afraid that it become a lecture actually. Yeah.
Let's say if we have water,
Yeah.
we can have ice as solid,
Yes.
water as liquid,
Yes.
and water vapor as
Yeah.
gas.
Yeah.
Then what would the water be in this state?
It become oxygen, hydrogen, hydrogen, and the electrons. So if you look at it, there will be a negative hydrogen. It might be a positive hydrogen.
Okay. So let's say from solid to liquid, we melt the solid,
Solid, yes.
and from liquid to gas, we
Boil.
boil or
Vaporize.
evaporate it.
Okay.
Then how do we transform from either the three states of matter into plasma state?
Okay, good question. Actually, if you look on the pattern, it's the same way. Okay, the same way from if you look at solid. So when you disturb the vibration, it goes beyond that localized position. It will go break down to the water. But what is water? What is liquid? It have a free movement, but some of the intermolecular forces still attract each other. Okay, so it's like a change. The liquid is like a change that is stuck by the intermolecular forces. So these intermolecular forces, all these forces is always there. But what the difference is the energy it required. Like say that right now you still bonded with your parents, right? But how come you can not staying with them because of your age? So we can consider that age is an energy. Okay, because as you go beyond a certain amount of age, so you have lots of energy. You can move around, right? So that's why I like about physics. Actually, you can see physics anywhere. Yeah. So it's just matter of energy. So when from the gas goes beyond to plasma, again, these neutral particles bombarding. So we have to go to the atomic model. So we go to atomic model. So does the actual atoms colliding, like the way that we viewing it? Actually not. They actually not touch each other. So actually what we call it as to touch each other is to the minimum distance. So this is all the perspective. So if we go to fundamental perspective, as I touch here, actually I'm not touching anything, but the reaction of the repulsion, the repulsion of the electron actually that produce the difference between it. So and then there's a sensor pressure absorbed through my mind and everything. So if you understand physics, actually you can explain everything how our body works mechanically, not biologically. Okay, but so that is the normal ways breaking up. Okay, high energy breaking up. But the plasma have a different ways to become a plasma. So that is one of the uniques of a plasma. Is that if you have even a solid, and then I have this, if you go to the condensed matter, if you have solid, okay, and then you have a free electron cloud inside of that, so this cloud can move around. So actually that almost is almost similar to a plasma condition, because the although it's solid, but if I remove all the electron cloud, it will become ions. It's not ions actually, because if you look, okay, my mind is a bit expanding, because that's why we have the course outline, so we don't go beyond that. So when explaining, actually we can explain it further. So if you remove that, we can assume that all the particles actually losing one electron. Let's say one electron. So the condition, although it's a solid, is still behaving almost a plasma condition. Okay. So another one is the one I said, the ionizer. Okay. Although that you don't need to increase the temperature of you using aircon. You don't want a lighter to be inside in front of your aircon, right? Just to heat it up to become plasma, because a flame is a plasma. Okay. How does a flame produce to become a plasma? Is due to the chemical reaction. Okay. So the chemical reaction also can produce plasma. Okay. Another one is the high electric field. The high electric field. Due to the very high electric field, the electron escape, the electron bombard to the neutral particle, and then it free the electron from the neutral particle, and then these two electrons have the enough kinetic energy to bombard another neutral particle. So the neutral particle outside is the electron, the valence electron, again bombard. So it continues like a lightning or corona discharge. Okay, if you look at the lightning is like a root, because if you draw the chain reaction of the fission, okay, you draw so you become like root. So why does it stop there? Because eventually it will have not sufficient of electric field to drive the electron to bombard the next neutral particles. So if you look at this, at first what I thought during those time, I don't have the answer. Maybe my answer was not correct also, because this is just a connective thinking, just thinking about what all the models that I've learned. So what actually happened when during the lightning strike, it's not the electric field produced at instant, okay, at instant. Actually what happened is the electron from the clouds, somewhere at that point, very high, so it have the electric field to inject maybe millions of electrons, and then this electron will drift towards the neutral particles, and then as the electron drift, actually it bring out the electric field. It's bring out, it's like you running, right? You running, lots of people. So when people seeing you, you will feel the force, right? You can see people running to you. Oh, what is that? I'm so run. Right? But as you scatter around, it will have lesser electric field. Okay? Have lesser electric field. Can you understand it? It's like you moving the charge.
But it's moving so fast.
It's moving so fast. So it's like a front charge. Okay, this front charge provide the electric field to drive more electron. Okay.
When we talk about plasma, we usually think of the lighter element and
The lighter
element, and obviously the noble gases, because
is much more easier.
much more easier. But in theory, we can make, for example, dual plasma. But is there any example people turn metal into actual plasma?
Oh, okay. There's a way, a process where we call it an ablation, or laser induced plasma. So laser induced plasma. So that's what interesting about plasma. Is to produce it is beyond of the normal ways. It's beyond the normal ways. Producing from solid gas, just heat it up and become liquid, heat it up, become gas. So you heat up gas, you become a plasma also. Yeah, because it vibrate more vigorously, and then the vibration will heat up the electron external, the valence electron, and then produce a plasma. But for, like your friend asked me just now, it's a solid can produce directly to plasma. So if I have a laser, and you know that what is laser, electromagnetic wave, it's a photons, and then where photons what does photons go? As you go here, you can see the light reflected, because actually it's not like you throwing ball towards the wall and then it goes back. Actually, it's not like that. It's not like that, but it's much more easier to explain like that, because actually it's behaving microscopically like that. Okay, but if you go down the fundamental, what is happening? So the electron absorb it momentarily and then release it. Okay, the variation of the absorption define the colors. Okay. Okay. Why did I go to that point? Oh yeah, laser induced plasma. Okay. So if you have very intense plasma, very intense laser light, so this laser will break down, will provide the valence electron or the even lower electron and energy, and then it ionizes. So when it ionizes, it already break the solid bond. So it already solid bond. So this, okay, let's just assume that this is a cylinder of light, a continuous of photons. As it moves down, Okay, this surface have absorbed the photons and then become an ion and electron, and then it's evaporating. Okay, evaporating, and then it's continuous. Okay, continuous, and then again evaporating. This all the movement of the charge already produce a current, because current actually is not. It's just describing the movement of charge, right? The rate of charge. So as it goes moving, it produces a magnetic field. And then as it goes along the way, the magnetic field produced, it will again pinch. So when it pinch, it's not just that happening. When the free electron and the free electron and the ion moving across each other, it will go much more smaller volume. It compress more smaller volume because of the radiation cooling. Okay, because you have the magnetic field confinement, but due to the electric force between the charge particle, it will have a force against it. So if you have a greater force, you will lose. It's just matter of equivalent force. So during those time, some of the energy of the ion and electron is changed to the electromagnetic wave. Okay, because we are dealing with the electron and the atom, and then as the electron slowing down, going near to the nucleus, it will emit electron. It will emit the electromagnetic wave, and then this phenomena will produce a radiation cooling, and then it will decrease more volume. And when it will decrease more volume, it continuously have the rest of the laser just now, the photon, and it will heat up. Smaller volume heat up, so it will have a high. It can produce high temperature and dense plasma. Nah, jadi macam lecture. Huh. Non-thermal process. Mm-hmm. What do you mean by? Let me rephrase back. You said how the question is how to determine the.
No, how I don't understand how the heat transfer in non-thermal process, and how the heat transfer in the plasma.
Heat transfer from plasma. From I understand what is a thermal process is due to the collision, right? Is it related to the radiation? Because I'm not familiar with the terms that you use. For my understanding is non-thermal process, that for a thermal process it's just matter of vibrating. If you go on the solid, there's the wave of phonons, right? Yeah, how the kinetic energy will transfer from collision from one to another, right? So for a plasma, there's more than that. Okay, there's more than that. Such a way that if you this side of plasma, okay, the electron lose some of its energy and produce the electromagnetic wave. It can be absorbed by its neighbor and been heat up. So this condition is what you call it? Not radiation collapse. I'm not sure about it. Where?
Doctor, actually 1 hour.
Oh, okay dah. Oh, it's pending.
Kalau if you are interested to explain.
Okay.
Maybe it's more to personal lah.
Yeah, yes.
Okay, so
Closing.
There's some like last word or
Oh, okay. For last word regarding on the 4 states of matter. Okay. The plasma, I want to emphasize that the plasma consists of very unfamiliar phenomena. Very unfamiliar phenomena. It's all
it's okay.
It's very unfamiliar phenomena. So actually we never yet explore, okay, because as you disturb one part, it will disturb another part, okay, because of the collective behavior of the plasma itself. So some say that the plasma itself is have the individual characteristics. Dia ada macam personality masing-masing. Plasma hidrogen macam ni, plasma apa heavy metal lain. Sebab kan dia punya reaction berbeza. So kalau kita mix up pun jadi lain. Lepas tu apa? If you go to this field, okay? If you go to this field, there's lots of possibilities you can explore. Okay? Lots of possibilities in terms of fabricating materials. It's required. There's a method using a plasma to fabricate materials in order to produce to energy studies also related to plasma in medication, because this plasma you can produce a very small amount of high energy particle which is stable. Okay? If you use a light or intense radiation, it might be more uncontrollable, okay, compared to a plasma. There's a plasma torch. You can make a skin treatment because of the plasma, the character of the plasma produced itself. Okay, so open your mind and explore plasma. Inshallah.
Okay, thank you so much.
Okay, welcome.
Okay, so kalau ada pesanan boleh lah jumpa doktor. Pesanan. Okay, sorry. Tak ada.